All right, now we're going to talk about porting and polishing. I'm sure you've heard the term, my heads are ported and polished or whatever. You know, that's a really misused statement there. You know, porting is one thing, port matching is another thing, and polishing is something totally different. Basically, what porting and polishing means, porting means getting the heads or the intake manifold to make a certain flow and to fit a certain size. What we're talking about like is the runners right here. Here's some intake runners. These are unported. These are as cast right here. You can see they're not very symmetrical. They're kind of off-shaped and everything. These typically don't match intake manifolds either. Intake manifold might have an entirely different shape or an entirely different size. If we look over here, these have been ported. You can see they're more symmetrical in size. It's not just about smoothing out the material inside or anything. You can see it is a little bit smoother in here, but that doesn't really have a whole lot to do with it. Polishing, you know, when they talk about polishing, no one on the street polishes heads. That's just a really no-no thing to do. Anytime heads are polished, when they're talking about like a mirror where it looks, you know, like chrome inside there, what happens when you're in the bathroom and you got steam inside the air? You know, do you see water droplets on the wall? No. Where do you find it? On the mirror. Why? Because the mirror is very smooth. And what's the idea of an internal combustion engine? The whole basis behind it is to burn atomized fuel. Well, if it's got beads of gasoline and droplets running down the intake runners just because they're over polished or anything, liquid fuel doesn't burn. Atomized fuel burns. So you don't really want to polish intakes. Sometimes people will polish the exhaust ports. The reason they'll do that is because carbon doesn't stick to it very well. So it tends to stay cleaner. When you get carbon buildup in there, it messes up the flow, and it's minute though. You know, on a street motor, it's not that big of a deal. But on a high horsepower, high-end race motor, when, you know, 1/1000th of a second might mean winning a race and not winning a race, and you got a bunch of carbon built up in there, it can make that much of a difference. But on the street, you wouldn't notice it in a million years. So no one on the street really ports and polishes their heads. It always has a little bit of a texture to it, which is fine. Nothing wrong with that at all. All right, so what's the other type of porting? There are port matching. Port matching is when you put a gasket up here, which I'll show you that a little bit later, but when you put a gasket up to the head or up to the intake manifold, and you only cut in like, oh, an inch, something like that, you're not doing the entire runner inside. That's port matching, and that's a good thing to do when you have aftermarket intake manifolds or performance heads. You always want to match the intake to the heads. And you also want to match the heads and the intake to the gasket size that you're using. We call that gasket matching or gasket porting or anything like that, or port matching. Let's talk about actual porting though. What's happening inside the head and what porting is all about. Let me show you just some basic fundamentals here. Here's just some basic water pipe right here. You know, we measure airflow and everything through here on what we call a flow bench. And at the end of this series, I'm going to show you that on a flow bench. But you'll notice on the flow bench, they measured in water. Because what is air? It's vaporized water, okay? So everything's measured in water units. 28 kilograms of water is a usual basis for measurement. So let's talk about air and water going through a pipe. If you're trying to plumb water through this pipe right here, it's going to come down, it slams into here, swirls around, and goes right on out. Not very efficient for making flow. You get a lot of reversion in here and just, you know, a weather system happening in here. That's not ideal. You know, if we had something like this, though, a very nice smooth transition, air coming down here, shoots around the corner, and just goes where it's going to go in a faster manner. And the whole key here in porting is not always size. It's not the bigger the better. I mean, that's for sure. Velocity is where it's at in most cases, especially for street performance. It's better to have a high velocity, high flowing head or a high velocity head will flow better than a big head that flows big numbers with a small displacement engine. And I'm talking small displacement like 350 to 400 cubic inches. You know, to us in a race shop, a big displacement motor is 555, 572, 614 cubic inches. Not something you normally run on the street. So when you see a race car running and they say, yeah, my heads flow, you know, 420 CFM, you're certainly not going to put a head like that on a 350 cubic inch motor and expect it to run very well, you know, below 10,000 RPM anyway. It's just not going to happen. So the trick is velocity. And what we mean by velocity, all it means is airspeed, how fast the air is flowing through there. And airspeed has a lot to do with it. Imagine this. I mean, if I took a blowgun from my air compressor and I blew it at your hat on your head, it'd blow it right off your head. And it's just coming out a little pinhole. Why? Because of the velocity of the air coming out and the pressure behind it. It makes flow. The whole idea behind porting is also the same thing. Create velocity, you create flow. So it's not always the bigger the better, trust me on that one. Another thing what we do in porting here, what you want to watch out for, are two unlike sizes right here. You can see the white one is definitely larger than the black one right here. Well, that can also be the same thing with heads. I mean, imagine this being the intake side, and it's going into the head right here, the head runner. Well, that's fine. You think, well, that's okay. But look what happens on the inside. Right inside here, there's a lip. So all the air going down inside there is going to hit that, and it's going to cause a reversion. As the air is flowing down right here, it's going to hit that inside lip and cause a back swirl. That's called reversion. That doesn't help any of the velocity or any of the flow, that's for sure. So the object to get it to work right would be to have two alike sizes exactly together. Now inside this pipe right here, there is no lip inside. It's just one flow to the next, a nice smooth transition. That's the whole idea between porting. And trust me, a 1/16 of an inch here, a 32nd of an inch there, an 1/8 of an inch over here makes a huge difference in flow. I mean, that can be, a difference between a ported head and an unported head. Let me tell you this. From a stock unported cast iron head, say the motor makes 350 horsepower. If you take the same head and you port it and you match the intake manifold, that motor can easily make 400 to 425 horsepower. It's an easy 50 to 75 horsepower, in some cases 100 horsepower increase just because of the head and the intake flow. That's nothing to shake a stick at. That's some serious horsepower numbers. So it's definitely worth doing. All right, this is a head right here that we've modified on a bandsaw. It's ported on one side here and unported over here with different valve sizes. Basically so we can see the intake and exhaust runners unported and intake and exhaust runners that are ported. Let's show you what I mean right here. This is what's inside of the head right here. We can turn this a little bit here. Just to give you an idea, here's the exhaust runner right here. This is where the valve is. We can turn this a little your way too. This is where the valve sits right here and closes against the seat. So when the exhaust valve opens, all the air comes out and rushes on out of here. And we can see that inside, I'll give you this one right here, there are pretty big lips right in here. There's a sharp corner right here. There's a sharp edge right here. That's not very good for helping airflow and keeping velocities up on the upper speed there. If we compare that to this side over here, here's one that's been ported. It's all smooth transition right here. It's a smooth transition, very smooth around here. It's also enlarged to match the valve size. If we look right here, here's the actual valve inside there. You can see what's going on. When the valve opens, it's a smooth transition right on out. No lips or anything to run into. If we compare it over here, there's some pretty sharp corners. You can actually see a line right there where a lip is. That's going to redirect the air towards the center and actually kind of compress the air inside there. Not real good. We just want it smooth flowing. Remember, the whole idea here is just to make a smooth transition and help increase the airspeed and flow to get fuel and air in the motor to make a bigger bang. And when you got a bigger bang, what goes in must come out. And if it ain't coming out, you're still, you have a constipated motor, which is not a very good thing to have. It's like having a great big breathing motor and a little teeny exhaust system. What goes in has to come out. And if it's too small, it can't get out. However, though, if it's too big, which is just like porting, if you go too big, you lose your velocity, which means you lose your bottom end torque, your bottom end power, your throttle response, all that stuff, and that's not good either. So remember I said that before, bigger is not better. But you can see the transition here is really nice and smooth. These are not polished. This is just a what we call a swirl polish right here. Let's look at the intakes next. All right, on the intake side right here, we're going to open one up on the unported side. Just give you an idea of what's going on inside here. This is where the air flows on in from the intake manifold right here, right on through. And again, we can see very large lips inside here, right there. It's going to redirect the air basically at the center of the valve. Well, the center of the valve right here doesn't flow. Air flows off the edge of the valve. So we certainly don't want to direct air to the middle here. We want to direct it to the edge sides. Also, this makes it smaller in here. It's not very big across here. I mean, the valve seat's way over here. And right in this area, we have a lot of metal in here that could be removed from there. Same with here. It could be removed off of here, could make a better, smoother transition. And again, size is not always what matters on this thing. It's again, flow and velocity. So we can look over here. You can actually see how the valve works, open and closing here. Here's where the valve opens and closes, just like this. So we don't really want anything inside here directing the air to come off here to slam it to the middle of the valve right here. We want to make sure it directs around and nothing here to deflect the air back. We just want a nice smooth transition to work it right off the seat of the valve, because that's how it's going to fill the cylinder. Let's look at the ported side here. There's one that's ported right there. As you can see, it's smoother transition here, no lips inside. It's all nice and smooth right in here. And I'm not talking smooth texture as in polishing wise. I'm just talking smooth as in no bumps or ridges or anything like that to redirect air. It's just a smooth transition. It just helps direct air to the face of the valve, lets it into the cylinder. We fill the cylinder, we make power, bigger bang, the motor goes better. That's the whole idea behind this here. So it's just porting doesn't have to go crazy on heads like this. A little bit goes a long way, and it's better to underport than overport. You can certainly screw a head up by just going in here and hogging everything out, and a lot of people make that mistake, and they just start opening everything up, and they wipe out a head. I mean, they think bigger is better, and they end up going slower than they did if they would have just left the doggone thing alone. So you got to be careful with this, and that's what I'm going to show you, is how to do this the right way. Just to give you an idea on the exhaust side, let's turn this around. Just one last thing. You can see the size difference as opposed to unported to ported. This is just ported to the large exhaust gasket size. This is a little big for the street. This head was originally ported for a little circle tracker that ran an open exhaust. But anything between these two sizes is fine. You know, and the shape, you just go by the shape of the gasket. And if you're going to buy headers, make sure the headers pretty much match the shape of the head. There's no sense in buying a round header when you got a square port right here. So just, you know, keep that in mind when you're getting ready to port, and what shape you're going to go with, and what size headers you're going to have, and what the shape of the headers are going to be. And we'll keep all that in check, and things should be good. So you want to port your own heads. You got to have the right tools to do the right job. I'm going to show you the basic tools and the bits and things to use and things not to use and where to get them. Basically, you need a die grinder. I mean, you're going to need an air compressor. Most tools are air-driven, so you're going to need a pretty sizable air compressor to do these kind of tools. They run quite a bit of air through these. So if you don't have an air compressor, you're going to need one, unless you want to go with an electric one. This is an electric die grinder right here. They work okay. They're a little cumbersome, but they do work okay. If you're just going to do it once or twice, this is okay. But if you're going to do it a lot, definitely don't want that. It's just too big and cumbersome. So basically this one right here is a 90-degree die grinder. I prefer these myself. I've been doing this for decades. I really like these. I like the way you can get in there and move. And these are obviously for removing metal, both cast iron or aluminum. I just like the way, you know, you can move this. There are straight ones right here. This is a straight die grinder. Sometimes you can get in there, use it like a pencil, or use it, you know, with both hands or whatever. These to me are a little hard to use. Some people really like these. That's fine. You know, to each his own. Everybody has their own little thing. But you're definitely going to want to use an air one. Next are the bits. What type of bits to use? Right here I've got some laid out. This is a single cut. In fact, this is a rough cut, single cut bit. Single cuts are for removing aluminum. As you can see right here, it's a single fluted blade, just like these, where one that's for removing cast iron is not. If we look at this right here, it's cut this way and this way. It's a cross-cut blade. You never want to use a single cut blade like this, especially a rough one like this one here, on cast iron. It'll just dull it right down. It's made for removing aluminum. It works real good for removing lots of metal at one time. To remove a little bit less metal, you'd go down to a smaller flute like this, where the blades are a little bit smaller. And again, here's another single cut right here where they're even smaller yet. And of course, there's different lengths and different shapes for getting into deep in, or you know, getting close to the edges or anything like that. But if you use a crosscut on aluminum, sometimes I'll even do that just to remove a little bit of metal. But it tends to gum up the blades, and you're constantly trying to clean the blades out. So really you want the right burr or bit here, right carbide bit for the right job. And the single cuts are for aluminum, the cross cuts are for cast iron. Then we go down here, we have a cartridge roll. This is just a sanding disc right here. This is for when you're done roughing everything out and getting everything pretty in shape that you want. You finish it up with a sanding disc, and these just slip onto the arbor right here. They squeeze on and squeeze off right here. They just slip on, and they self-squeeze because they're tapered right here. And what these do is they just take off little tiny imperfections and give it the finish that you want. If in fact you are going to polish your exhaust ports and you're going to have a high revving, high horsepower engine, we would use a cross buff. And it's basically Scotch-Brite type of a material there that just screws onto onto an arbor right here, and it just polishes what this sanding disc couldn't get off. This polishes the remainder of the way, and takes off very little material, but just gives it a really nice sheen, and that's a good thing to do. A thing not to do, this is not a porting tool, okay? This is a drill. Don't use a drill on a grinding stone. You're not going to get anywhere. You're going to be there all day. You're going to tear up a set of heads. It's not worth it. I know a lot of you probably have these at home. I've seen guys try and port heads with drills. All you do is burn the drill out and just ruin a set of heads. Die grinders are cheap. You can buy one of these things for as little as 20 bucks. An expensive one is 75 bucks. It's cheaper than this drill right here. So don't burn up an expensive cordless or powered drill when a die grinder will last you forever. I mean, they go, I've used these particular die grinders right here, especially this one I've had for like 20 years, and it's still going. And I've got 3 or 4 of these that I use, and I don't think I've ever replaced them. Where a drill, you're not going to get through one set of heads before you burn that thing out. So try and use the right tools for the right parts and doing the right job, and you'll get a good job out of it. All right, I'm going to show you how to port a head here. First thing you want to do is start off with a junk head like this one right here. Don't do one of your good heads if you bought a brand new one, or you're going to use a head that you're going to use on your car for the first time. It's probably not a good idea, because if you remove a little too much metal, you can't go back. So it's better to practice on something that's just an old junk head. You can go to your wrecking yard and just get one for almost nothing. First thing you want to know too, when you're getting ready to port, this is why we're in this area of the shop right here. This is our dirty areas, our fabrication area, where we weld and grind and do whatever. You want to do the same thing in your little garage or your shop. Metal flies everywhere from the die grinders. I mean, they're spinning at about 15 to 20,000 RPM, and it throws metal in places that you wouldn't imagine metal can get into. So do it in a dirty area. Don't do it in a clean area near your open motors or anything like that. First thing you want to do though when you're porting is pick a gasket. We're going to start with the exhaust side right here. And pick a gasket that matches your headers, or fairly close to the header shape on the ports. Usually they're kind of a square like this. This is a Felpro 1404. At the end of this series, we're going to have a whole series of numbers for the head casting numbers, gasket numbers to use and stuff. So be sure to check at the end here. We'll give you all the numbers to look for. This is a 1404 though. It's very common shape. All you really want to do is just set it on here. I like to use a couple of bolts here just to drop it on. That helps hold it in place, just like so, and just like so here. That holds it in place there so you can get your hands for free. Just take a scribe, and what you want to be sure is that you're centered on the bolt holes right here. You don't want to have it down, you don't want to have it up or anything like that, and just scribe the hole right around where you want to go right here, and do it on each port right here, all the way across, and that'll give you an idea of where you're going to cut the head. Now you'll notice too, I'll do a couple of them here for you, just so we can see what it looks like when we're done here. There we go. You'll notice here, you can see the material that needs to be removed. I mean, here's the gasket area right here, and here's how much metal, that needs to be removed to match this gasket right here. This is what we call gasket matching, or port matching, because we're matching the port to the gasket, which hopefully the gasket matches the headers. It doesn't look like a lot of material needs to be removed, but just keep this in mind. Going from a 194 valve to a 202 valve, that's only a few thousandths of an inch, it's not a whole lot. It's not like it's a 1/4 inch difference or an 1/8 of an inch difference or so. So same thing with here, that's maybe an 1/8 of an inch of metal right there. That's more than a difference between valve size, going from a medium-sized valve to a fairly large valve. And a lot of people don't blink at putting bigger valves in their heads. Well, it's the same thing with here. That's a lot of material to be removed. That increases flow by quite a bit. So let's take a peek at this, what it looks like right here, just to show you the scribe marks on the exhaust side here. I'll pull the little bolts out. Now if you look close, you can see the scribe marks right here, right as they go around, right there. That's where we're going to take a die grinder and cut right on out to. And porting is not cutting just from a little edge right here out here. We're not trying to make a funnel with this, okay, at all. What we're trying to do is shape the whole port inward so the whole port is that size. Funneling does nothing. I mean, it still has to go from the small side right on out, okay? And that's not what we're trying to achieve here. That's not going to get you any more flow. What's going to get you more flow is to shape the entire port on inside, right on down. If you're going to port match, even just minorly, you at least need to go in, an inch, okay? Some people say a half inch. Half inch isn't really enough. That's too steep of an angle. Air is not going to come out and all of a sudden jump out like this and go into the headers. That's not the way flow works. It needs to make a smooth transition. But that's where we're going to cut the metal off the head. Let's do this. Let's flip this over, and we're going to do the same thing to this side right here, which is the intake side. Now, mind you, I'm using stands right here. You can just put a head on a bench and just use a piece of wood underneath it, a 2x4 or a 4x4, and block it up to get whatever angle you want. Or you can buy some headstands like these, just some universal headstands. They're not real expensive, and most of the part suppliers and performance warehouses, they carry these. You can order those. So let's look here. Now, this is a Felpro 1205 gasket. It's a medium-sized race gasket. It's not big, but it's not small. It's certainly bigger than a stock port. So we're going to look at right here. We're going to put it on like so. Again, we'll take a couple of bolts just to help hold it in place, just to give you an idea of the port size difference here. And mind you, again, it's not how big the ports are, it's the shape, okay? Sometimes you're not only trying to increase flow, sometimes you're trying to increase velocity too. Remember, velocity will make flow. So if you can increase the velocity sometimes, that's just as good or better than increasing the size of the port to increase the flow. So if we look here, you can see right here, there's quite a bit of material that can be removed off of here. We got these centered on the bolt holes right here. We hold that flat. You can see, right, in this area here, there's quite a bit of material. Let me scribe this out here. We're just going to hold it tight, go around it right here with a scribe, and this will give us the idea where we're going to port on this thing. Try and hold the gasket tight, because if you move it around, you're going to get an incorrect scribe mark, and you'll be cutting in the wrong area here. Let's go in here, get right around. There we go. Let's pull this off right here. This will just give you an idea of how the size difference and how big we need to go on this to match the gasket. So if we look, we can see the scribe mark. They're not very prominent, but you can just see it right there. The line runs down right over here. Now on porting, this is what you need to know. Of course, the head's upside down, so this is the roof. This area right here is the most important area. The floor isn't a whole lot. I mean, I'm sure you've heard of raised port heads or high port heads. They raise the ports because all the flow and velocity is usually up along the roof and the high-speed area. The floor doesn't really do a lot. In fact, some people raise the floor. They'll put epoxy or they'll weld on aluminum heads. They'll TIG weld down here and raise the floor up a little bit. And then what they'll do is work on the roof line area. So on the floor, you don't need to pay too much of attention, but the roofing area you certainly want to. Here's the scribe marks right here. So this is where this head would be cut out at. And again, we'd want to go in at least an inch to port match this. If we're going to do a full port job, of course, we go all the way down in and blend the whole thing to the same size. But just a good transition about an inch in will do the job for you. And usually a port match on an intake, from an intake manifold to a head, it's worth anywhere from 10 to 20 horsepower on average. Of course, some might make 5 horsepower, some might get 25. It depends on how bad the natural shape of the ports are when you start. And not every engine's the same. It also depends on the cubic inches of the motor. I mean, if it was a 283 Chevy here, you're only going to get so much horsepower out of it. But if it was a 434 or a 454, a monster stroker like what we build, a 454 small block, that's a big cubic inch motor. Of course, you're going to get a different gain out of that. There might be a 25 horsepower difference. But that's where we're going to cut it. We'll go to cutting next here. All right, before we get started, there's a couple little quick things you need to know here. First thing, you know, the die grinder, you got to be careful with these. These bits are sharp, and these do spin at about 20,000 RPM. Second thing is, remember what we talked about before on the bits. This is a cross-cut bit, which is designed for cast iron. This right here is a single-cut bit, which is for aluminum. You don't want to use one of these on cast iron because it'll dull it immediately. So you want to make sure you have a cross-cut bit right here. Second thing is a safety. You want to make sure you wear eye protection and face protection. I wear prescription glasses with tempered lenses, so I usually don't wear the extra safety glasses because I already have them on. But you do want a little bit of lung protection. Grinding these is not the way to get your daily iron, okay? That's just not good. If you do a lot of it, it's just filling your lungs up with iron, and that's just not a good thing. So you want a little protection right here. And of course, I happen to have mine right here. So what we're going to do is take a peek at the port right here, and we're going to do a little grinding. And what we're basically going to do is start just shaping the port a little bit right on out to the scribe line here. So we're going to get right in here and just keep a light grip on the die grinder. And just get right on in here and just give it a blast here. Here we go. Now, if you look close here, I've already come right on in just to the edge. We'll get right on in here to this edge. All right, now I'm right along the edge right here. I'm right at the line. And that's fine, but we're funneled in. So now what we want to do that shape is work the inside now to match that. So just be careful you don't go beyond that point. And again, just keep a nice light grip. You can use your hands in any motion you like. I like the 90-degree angle grinders like this. Some people like straight ones. I don't like to have my hands like this. This is more of a relaxed position. But we're just going to work on the inside now, right on inside here. You know, while I think about it, let me tell you something here too. You want to keep the bit moving at all times. Don't just hold it in a corner or in one place, because you're just going to make a divot that's going to be really hard to get out. If you keep the bit moving, it'll keep the metal being removed in a smooth transition or in a smooth way. If you hold the bit in one place, it's just going to dig a hole, and they're really hard to smooth back out. Another thing is, plan on being here for a while. Porting takes time. It's grueling work, but it pays off in the end. I mean, the horsepower gains are pretty substantial. But on a cast iron head like this is the worst to do, is cast iron. It's going to take you anywhere from 2-3 hours on a head just to do a gasket match on a head, on up to 8 or 10 hours to do a full port job. It's not unheard of to get anywhere from 15 to 20 hours into a set of heads to do a good port job on them. But just keep at it, do a little at a time, and you'll do real good with it. Okay, here's a different head right here. This one's already done. So we can see right here, this is what the factory port looked like. It's the same casting number as the last head we were doing, so it's the exact same head. This is an unported one right here, and this is one done exactly to the same gasket, the 1404 Felpro that I showed you, and this is what it'll look like when it's done. This one's done quite a ways down inside there, and it's all finished off. So when you do a good job, this is what it should look like in the end. All right, when you're done with the exhaust side, you can start on the intake side. Of course, you can start on any side you want, whatever your preference is. But we're going to do the intake side now. As you can see right here, here's our scribe lines. You can see pretty clearly right there. And again, this head's upside down, so this is the roof area at the bottom here because the head is upside down. This is the side we really want to pay attention to. This is the high velocity side here, up on the roof line here. So again, we're going to just put our little lung protection on here, and I already have eye protection on. So we're going to get in here and just kind of shape where we need to cut right against the line here. Here we go. Okay, if you look real close here, grab a little pointer so you can see, I've already cut it right out to the edge of the line. Didn't take that long, but we have this funnel shape here. It's now just working its way in. So the port inside here is still small. So just because we've cut it out to that line doesn't mean anything at the moment. You're not going to gain anything by that. So we need to blend it inside so it makes that smooth transition again for the airflow to go from the intake manifold into the head port here, and then to work its way down through the valve and into the combustion chamber. So we still need to blend inside there. So we'll go to that next here. All right, so that looks pretty good right here. We're right up against the edge, right against the lines right here, nice and straight and smooth. And you can see that I've gone in about an inch here, which is good. like I said, we don't want to do that first 1/4 inch or so. That does nothing. That just makes a little sharp-edged funnel, and that's not what we're trying to do here. Smooth transition, a smooth airflow. You know, we don't want any abrupt changes inside the runners here. So I've gone in about 1 inch right here. It's shaped pretty nicely. That's real good. That's what we want to do to all these. One thing I want to point out here, small block Chevy heads, of course this is upside down, but there is a bolt hole right here which holds the valve cover on. There's 1, 2, and then on the other side, 3, 4. When you're cutting on this edge right here, there is a bump right here, a boss area that's cast into the head. It's not uncommon to cut into the bolt hole area, into the threads. All is not lost. That's okay. There will be a bolt in there. You can put a little thread sealer on that, and that's okay. So it is common sometimes on some head castings to actually cut into the valve cover bolt holes, but that's all right. All right, well, here's a head that's finished off here. I'll show you what the intake runners look like. Of course, this is, again, the same casting number as the junk head we're using, so it's pretty well identical. So this intake port right here hasn't been touched. This is what it looks like as cast, just like the other one was. And here's the one that we finished off. And it's not that much bigger, but it's a little bit bigger, and it's definitely more symmetrically shaped and smoothed off and blended inside, which will just help increase the airflow and velocity, which is what we're after. You can see I went down pretty deep inside here, which is good. I mean, that's the whole idea. We want to make a smooth transition for the air to go, and that's the whole object of this. Speaking of getting down in there, let me show you what we've done here. You know, the bits we normally use are just a short little bit like this. There are longer bits that we can use, such as this, that help you get down deeper inside there. You know, when it's on the grinder, you can get it right down in there and get as far in as you want. A lot of times when you're just gasket matching, that's not necessary. Just 1 inch or so in is fine. If you can go 2 inches in and you have the time to do that, that's even better yet, but at least 1 inch is good. That'll do that. And then to finish off, we use these right here. This gives it a nice finish. These are called cartridge rolls. This one's slightly used. Here's one that's brand new right here. And what it does, they're just sanding discs is all it is. And what it does is these just come off. They just screw on and off of this arbor right here. You put another one on, give it a little twist there, put it in the die grinder, and you can work it around in there, and this takes off just a little bit of material, not a whole lot, but it just gives it a finish that's real nice. And again, we do not polish intake runners like this. Intakes you certainly don't. If you polish it, all you're going to do is beat up the gas. It's going to form droplets. Liquefied gas does not burn. Atomized gas burns. So you do not want to polish the intake runners. You want them with a slight texture to them, and that keeps the air-fuel mixture in a atomized state. All right, now we're going to be in the bowl area, which is behind the valve. You know, a lot of people think that the intake runner or the intake port and the exhaust port is where the power's at, and that really couldn't be further from the truth. There is a little bit of horsepower hidden, like I said, for gasket matching and stuff like that, but really where the power is all at is in the bowl area, what we call the area behind the valve, or the pocket area. Some people call it pocket porting or bowl blending. That's really where it's at, and I'll show you why. This head right here has been fitted with hard seats already. These are tungsten steel seats. They're a hard seat that way you can use for unleaded gas. It also allows us to put a larger valve inside there. Let me show you something here. You know, this is the seat area right here on the edge. And as you can see inside here, where we've taken a cutter on the mill to install the seats, there is a large lip inside here. Because the valve is going to be larger, the pocket here isn't. And let me show you here what I'm talking about. This little caliper set here doesn't fit in there. That's barely fitting. But look at the valve size. That's a huge difference. That's at least 1/8 of an inch difference right there. So there's no sense in going from a 1.50 inch exhaust valve to a 1.60 inch on like these, what we call a 150 valve to a 160, when you haven't done anything inside here. Because you might have increased the valve size, but you haven't increased the flow capacity or the flow capabilities inside the pocket area here. And this is where all the horsepower is hidden, right here. Of course, if you're going to do this, you definitely want to gasket match it too, but you don't want to do this and not gasket match. It's okay to gasket match and not do this. Of course, you're not going to get the good power out of it, but you don't want to do this and not gasket match. So we're going to do this here. I'm going to show you how to cut this area here. Put our nose protection on here. You know, another good idea might be to wear some ear protection. These die grinders are noisy. They make a lot of sound. And when you're here for hours and hours, it's going to wreak havoc on your ears. You might want to wear some earplugs. So we're going to give you an idea of how we're going to cut in here. We're just going to go in here and just cut this lip area out and just make it a smooth transition right on in where it comes out of the listed exhaust valve here, so it can flow smoothly out of the exhaust valve right on out the exhaust port here. So we'll cut this here. You know, one thing too I want to tell you before we continue on here, if you notice the valve seats are not cut on this. You want to be careful. I've been doing this for a couple of decades, so I'm pretty good at it, but everybody makes mistakes. If you notice the valve angles here, the valve seats are not cut. You definitely don't want to port your heads after the valve seats have been cut, because if this thing bites and slips, you're going to cut right across the valve seat there and wipe out the seat that was just ground already. So you want to do it before you do that and then cut the seats afterwards. So don't work backwards against yourself and have to send the head back and have it reground just because you made a little mistake and the die grinder jumped and ran across the bit like that. Not a good idea. So if you notice, these don't have the facings on them yet. And that's what I wanted to give you, show you that there. All right, so this one's getting pretty well done here. Let me just kind of give you an idea where we're at now. These are the same calipers that we had before, and you can see before they wouldn't fit in there. Now they fit in real nice. It's just a smooth transition. What you want to do on these, you want to pay attention to the short side radius right here. Make sure it's a nice smooth blend. And the high velocity side here is the roof line. Just like on the intake runners, the exhaust runners are the same thing. The roof line is where the high velocity air is going in. It's very similar, I mean, airflow is very similar to, like, you ever see ice skaters on an ice rink where they got someone that stops in the middle and they have a whole line of people and they go in a big circle and everybody on the outside, they go so fast they fly off. That's because that's the outside area. Well, the same thing with runners. The short side is the slow side, but for the air to keep going, the outside is really a higher velocity area there. Very same thing inside of ports here. So the short side, you want to make sure there's a real nice radius, and then the high side is the high velocity side. So that's why some ports have raised runners or rounded roofs and flat floors and stuff like that. There's many different shapes. There is no one perfect shape. If you look at a top fueler, the exhaust ports are square, and the intake ports are pretty rectangular. You look at other motors like the famed Boss motors, the Boss 302s and stuff like that, they're big oval ports. It just depends on what you're doing there. Let's get in here and we'll go back to grinding here and we'll go to the next step. All right, that's about as far as we're going to get on that. It's a nice smooth area there. It's going to be a nice transition from the valve seat right on up in and out the port. Now we need to do the intake side here. Now there's different types and styles of bits. I showed you different lengths before, where we have a short one and a long one. There's also different shapes. They call these a tree sometimes. Sometimes they call these an olive or an oval. There are round ones also, just like this. Different shapes for getting into different areas. I've been using this shape bit right here, which is pretty common. Another common one right here is the olive shape like this. It's just for getting into rounding off different areas. So I'm going to do the intake run right now. So I'm going to change bits. Some people like short bits. Some people like the longer bits. Sometimes it's easier to use one than it is the other. I'm going to go ahead and use the long one here so I can reach down inside this intake port a little bit better, or the bowl area here a little bit better. So I'm going to do the same thing that I just did to the exhaust right there. We're just going to make a smooth blend right here. We're going to try and take this lip out, and I'll try and show you this here, what we're talking about. Here's the valve seat area, and as you can see, it necks way down in here. There's a lip. There's almost a 1/4 inch of material there that can be removed to make a smooth transition as it comes down the runner right into the valve area here. So we're going to take all this metal out right here just to make a nice smooth blend so we don't get a funnel effect or anything like that. Just a nice smooth blend. So I've got the new bit on here, got my protection on. Here we go. All right, well that looks pretty good in here. Remember I said keep the bit moving, don't hold it in one spot. You get a nice smooth finish right here. And again, smoothness is not what we're looking for, but a smooth transition is what we're looking for. So right here we can see, give you a little pointer here, now the lips are gone. It's just a nice smooth transition for the air and fuel mixture to come right on in and fill the combustion chamber. Let's look right on over this side here. Here's what we had to start with. You can see, man, there's at least a 1/4 inch of material right there that's just blocking the fuel air mixture and directing the air at the center of the valve. Well, the center of the valve is solid. I mean, that's not where the air and fuel flow at. It flows from the edge. This is the seat area right here. So we want to try and direct it towards the seat facing area to fill the cylinder. So all that material there we moved. All right, here's the finished head. Again, it was the same casting numbers as the junk head we're using. So let's look right here. Here's what we started with. This is just a unported set of valve seats right here. You can see the lips that we had inside here. That was the whole idea of cutting that out of there. We come over here. These are the ones that are finished off. And you can see there's a big difference between the unported ones and the ported ones. And again, this is where the hidden horsepower is at. Nice smooth transitions, very nice smooth transition on a short radius side. The high velocity side's the back side, remember the roof, and it comes down the back, makes a real high velocity, high flow side. This is all smooth transition now. We've gone in and cut down inside here the valve guide area a little bit, rounded that off, opened the sides a little bit. In fact, if we come over here, this is the one that's completely finished off. We've gone as far on this one too as to take a cartridge roll like this right here, that right there, and sanded the inside of the combustion chamber there just to get hot spots off. The stippling and the little ridges and peaks that are inside a combustion chamber just from the natural casting texture, those can become hot spots. And by some people call this polishing. It's not really polished, it's just deburred. By deburring it, it just takes any hot spots off or anything, which could cause detonation or things like that in a really high horsepower, high compression motor. But again, the whole bowl area is done, both on the intake and exhaust. Very smooth transitions, just a good way for fuel and air to flow in and hot gases to get out, and that's the whole object of making horsepower. Get it in, bang it, get it back out, and big horsepower. So this is what we should look like when we're done. Okay, what we have here is your typical aluminum manifold. It's a Edelbrock Victor Jr. Great manifold for medium to medium high performance motors, anything from 350 to on up to about 500 horsepower. Just wanted to let you know, when you take a performance manifold like this out of the box, they're figuring that you're going to need to port these. I mean, this is a race manifold, okay? So they make the ports small on these. In fact, let me give you an idea right here. This is your typical race gasket. It's a Felpro 1206. And we drop this on here, you can see that quite a bit of meat needs to be removed out of this area right here. There's, that's pretty small. This is the size of the heads. Most performance heads that are designed for this type of an intake manifold have this size port on them. So you go taking this manifold out of the box thinking you're going to get an extra 20 horsepower or something like that, you're fooling yourself because it's not cut yet. You need to cut them first. And you can see that's a lot of meat right there. And again, if you put it in terms of like valve size, I mean, going from a 194 valve to a 202 valve is less size difference than what's right here. And you're talking about not just this side, you're talking about the roof, the floor, the sides, and everything. I mean, that's a lot of area. Times that by 8 cylinders, that's a lot of horsepower that you're losing right there. So you can't just take one out of the box and expect to put it on and make horsepower. Let me show you one other thing right here too before we start. This is the plenum area. This is an open plenum manifold right here. Okay, or what they call a 360-degree manifold because it's 360 degrees of area right there. There's no divider. Don't mess with the plenum area when you're porting. That's really a no-no. You can go in and just take a little casting flash out of there if you want, but don't go crazy on the plenum area. These are really touchy, and if you get in there and you knife edge the runners right here and stuff like that, you're going to really mess it up. Don't do that, okay? So let me show you right here one that is ported and one that's mediocrely done. Here's our gasket right here again. We'll put this on here. This is what I see manifolds come in looking like sometimes. Here's the port right here. Okay, and you can see this is really poorly done. I see manifolds come in, or actually motors come in that someone's ported the heads on or port matched an intake manifold, and it looks like this, and that's crap, okay? Don't even bother. If you're gonna do this, don't even waste your time. That did absolutely nothing but just screw it up. It didn't go in deep enough. It's too steep of a wedge. It's not symmetrical. I mean, it looks like someone took a drill and a stone to it, and that's about what will happen if you try and do that. Don't do that. It should look like this. This is what it's supposed to be like when it's done. A smooth transition. It's gone in, 2 inches or so inside the runners in there. Fits the gasket perfectly. That should be a really nice size right there. It'll match the heads perfectly, and that's what we're after when we're doing this. We'll show you how to do that next here. All right, well, here's our gasket. We have it on here, and I showed you how to do that before. Use a couple of bolts. These have nuts on the back side because the intake manifolds are not threaded. So put a nut on the back side. What this will do is help hold the gasket in place. Nothing worse than trying to hold a gasket with your hand. You're trying to scribe, and the gasket moves, and you scribe off where you want to be. So just put a couple of bolts in there to hold it in place. You can still hold it down with your fingers, and just take a scribe like this, and just trace around the gasket. This is exactly what we're looking for here. Let's go right around the port. This is where we're going to end up cutting to this point right here. I'll do both sides here. And again, allow yourself plenty of time. This is not going to happen overnight. To do a intake manifold, it takes a couple of hours, an hour and a half to 2 hours to do a good job on a manifold. Of course, I've been doing this a real long time, and I've probably done hundreds of manifolds and too many heads. I mean, more heads than I care to remember. But as you get better at this and time goes on, it'll go faster. You'll get a little routine down that works for you. And like I said before, everybody does things their own way. I mean, some shops might do this a little different. That's fine. This is the way we do it. And we've been doing it a long time, and it's a pretty common way of doing things. But as with anything, and anything else I've shown you in this series here, degreeing a cam or finding top dead center or this or that, everything has its little differences between one shop and another. This is pretty common stuff, though, and I'm trying to show you the easiest way to do stuff that is what I call bang for the buck. More bang for the buck for you, less time consuming, and just to get you down the road and get you some good horsepower. So here we have it right here. It's scribed up. And I'll pull this off and be back in a second. I'll show you what it looks like after this. Okay, and here we have it with the gasket removed. And of course, here's our scribe marks right here, as you can see right on in. So we're going to take all this material off right here. Again, that might not look like a lot to some of you, but really that's quite a bit. And again, you times this right here, this area here, and a little bit on the inside, times 8 other cylinders. That's quite a bit of horsepower. And like I said before, port matching an intake like this can be anywhere from 10 to 15 horsepower, sometimes as much as 20 horsepower, depending on the displacement of the motor and how bad off it was to begin with. So we're going to cut that there. Again, we're going to use this is aluminum, so we're going to use a single fluted bit. This is a pretty large flute right here for rough cutting. It takes a big bite out. You've got to be careful of these things right here because they tend to grab and jump. So you want to kind of get a firmer grip on this one. What I'm going to do is on this side here, I'm going to cut the really bad looking one out here. It's already scribed to the same size, so we're going to cut it on this side here and get it all shaped and nice for you. Another thing that I can't emphasize enough, eye protection. Again, I wear prescription glasses, and so I tend to not wear extra glasses on top of these because it's hard to see. And nose protection, a little lung protection here, and you probably want to wear some ear protection. These make quite a bit of noise. A head is more of a solid chunk of metal. This is a little thinner area here, and it's going to sing a little bit, so ear protection might be a good idea. So we're going to get on in here, and I'm going to try and finish up with someone butchered here, okay? So here we go. Okay, I'm pretty well done, hogged that out now. Again, this is a pretty big fluted bit right here. It's made for taking lots of material out. Now I'm going to do a little more finish work on it and take a little less material out, so we're going to change bits here, okay? So we're going to go to one that's a little less aggressive of a cut and get this thing just about finished off here. So I'll pull this off. I'm going to go to this one right here. That one right there, you can see the flutes are a lot smaller. It's a different shaped bit. It's a little less aggressive. So we'll pop that in here, give it a little cinch up, and we'll be on our way here. Oh, before I forget, remember, keep the bit moving. Don't hold it in one spot. Even when you're trying to shape a corner area out, don't just hold it there and grind in the corner, okay? Because it's hard to get that divot back out. Always keep it moving. If you're in a corner, keep rolling it back and forth like this, and that'll get the shape that you're looking for. You can do a little bit of back and forth like this, up and down. Again, though, if you keep doing that or you just hold it in one spot, you're just going to burn a hole into a spot. It's going to be hard to get out of there, okay? So let me kind of give you a little idea here of what we're talking about. Well, that's shaped pretty well right now. We're right on up to the edge of the scribe line that we wanted to get at there. And now what we're going to do is put a finish on it. And I've showed you this before. This is the little cartridge roll. This will put a nice desired finish on there. And again, you don't want to polish intake runners at all. So we're not going to polish this. Nothing more annoying than someone saying, I got ported and polished heads or whatever. And it's like, if they're ported, okay? But no one polishes this stuff. So don't do that. We want to be sure the air has a nice textured finish, a slightly textured finish to keep the air-fuel atomized as it goes down the runners and into the combustion chamber. So we're going to switch here. Again, we're going to undo our air here. Don't try and change bits on a die grinder that's plugged in. All you're going to do is cut your hand open. So always disconnect that. I'm going to go here, I'm going to change this bit out. I'm going to go to the cartridge roll here. These come in all kinds of different grits. They come in 36 grit, 60 grit, 80 grit, 120. You can change different grits. You know, this one right here, I think it's a 80 grit. It's kind of an all-around medium grit to go to. Put a decent finish on here. So we're going to go right on in. This is real simple. Doesn't take very long at all. I'm going to finish this up. All right, well, that put a nice finish on there. I'll give you an idea here of what we originally started with and what we ended up with. Here it looks a lot nicer here. You can see I've gone in probably 1.5 inches to 2 inches here. That's a real nice blend. Gives it an area to go in there. Remember, this is a 210cc runner intake manifold. So what they do though is when they neck down, as we saw when I showed you out of the box, they neck them down. They're assuming you're going to port it because it's a high performance motor, and hardcore high performance motors usually have ported intakes and heads, so they assume you're going to do that. So we've done that. And you can see the difference here from what we started with someone hacked up right here to a finished product. Just to give you an idea time-wise, I probably had between cuts on here when I was doing this to show you the finished right here. I probably had about 8 minutes in this port right here. Didn't take that long. So, you know, like I say, you're going to spend maybe 1.5 hours to 2 hours on an intake manifold from start to finish. When you're done with this, kind of a good idea sometimes to go along and deburr the area here that meets the gasket. Sometimes a little rough edge right there. You can take the cartridge roll and just touch a little bit, or a little deburr. Next important thing too is wash them out when you're done. Make sure you really wash this thing out. Get a brush in there and get all the particles out of here. You don't want to just try and do this and then blow dry it out and put it on the motor, because there are particles that'll be stuck in there and they'll end up in the motor, and they're going to get between a piston and a ring and, you know, wipe a cylinder out or damage a cylinder, and that's just not what we want to do. Another thing too, keep in mind when you're porting, the whole idea of porting, remember, is for a smooth transition, you know, from the intake manifold right on through, right into the head and the combustion chamber, right on out the exhaust port, through the header, and right on out. Smooth transitions. We don't want different sizes of runners and things like that, and gaskets and headers. The idea is just one smooth transition, no hard corners or anything like that to go into. So again, you don't want to take like a 210cc intake manifold like this and put it on stock heads. And you don't want to take a small manifold, let me give you an idea, like a Performer Series manifold, and put it on Victor Jr. heads or Dart heads or anything like that. Any of the great heads that are out there that are aftermarket heads that have large cc runners, 210, 220cc runners. That's a mismatch. You got this, you know, decent sized carburetor going into this little teeny port runner intake manifold, going into big heads, probably necking down to little teeny headers or through into a small exhaust system. It all needs to work together, and if you get it all to work together and you get the proper intake manifold sized to the proper size heads and a proper exhaust system, your motor will make a lot of power and your car is going to go. It makes a difference of being fast at the track or not being fast at the track. And little simple steps like this will get you going a lot faster than the average guy at the track who just took this out, bolted on, and thinks he's going somewhere. And that's pretty much the name of the game on this. All right, we're here at the flow bench with Mike here. This is one of the Ford heads that we talked about in an earlier segment, where I took each combustion chamber and started with a stock set of valves. This one's got 351 Windsor valves in it. This one has Chevy valves, and this one right here is ported with unshrouded valves and Chevy valves and all that in there. So we're going to see the flow characteristics and the differences on all the different heads. This is a very popular high-end flow bench. It's a Superflow 600. It's industry standard. Basically what we're going to do is measure it at 28 inches of liquid, which you'll be watching the scale right here. He'll be measuring everything at 28 inches, which is an industry standard. Most people measure heads at 28. That just kind of gives you a run-of-the-mill CFM that most other shops use, so we can compare different heads and different flow rates in cubic feet per minute. So you'll be seeing the liquid come up here, and then Mike will be taking a reading up here, and then we'll calculate it out. We can tell you the different flow ratings at the different lifts. We're going to be testing this head here at 300, 400, 500, and 600 inch lifts, okay, or that's 300 thousandths, 400 thousandths lift, because we want to give you an idea of what a mid-lift flow is and what on the high end is. And most street cams are up in a 500 lift, 550, 600. So we're going to see if these heads flow good up there, if they don't flow good. So we'll let Mikey take it away here, and we'll see what happens. right, here's the test results or the flow results of the stock valves and the stock chamber on the factory forward head. And on the intake side that we just did here, at 300 lift, we had 147.1 CFM of flow. At 400 lift, we had 167.7. At 500 lift, we had 174 CFM. It's not bad. And at 600 lift, we had 179.5. But let me point something out here. He went ahead and bumped it up to 620 lift because that was where the valve finally maxed out at. And at 620, it actually dropped. It went back down to 179. We lost a half a CFM. The reason I want to tell you that is if we had a 600 lift cam on here, we would have maxed out at 600. If we had a 620 lift, that extra 20 thousandths, all it's doing is beating the hell out of the valve train and the valve springs, and we wouldn't have gained any flow. That's one of the things I want to point out on here, why we're testing it at different flow levels and seeing where these heads flow at, both CFM-wise and where they peak out. So we'll give it to Mike right here again. We're going to test the exhaust side, and we'll come back and give you the results of that next. All right, well here's the flow results in cubic feet per minute, or CFM, on the exhaust side of a stock Ford head. This is a small block Ford head. We're talking at 300 lift, 83 CFM. That's nothing. I mean, that's really bad. At 400 lift, which is your average RV style cam, somewhere's in there, 103 CFM. That's still nothing. I mean, that's really low. At 500 lift, or what they call a half-inch lift cam, 113 CFM. That's still real small. All the way up to 600, it did flow up to 118 CFM. But you got to keep in mind here, you're not going to run a 600 lift cam in a stock head like this. He bottomed out. The valve springs would have had coil bind. You couldn't get to 600 on a head like this. So I'm just giving you comparisons of what they can do, but in reality, you couldn't get up there anyway. You'd be hard-pressed to get 500 thousandths lift out of a stock Ford head like that. So even at that, 113 CFM is about as max as we're going to get out of a head like this. That ain't very much. All right, now he's going to test the next chamber here, and basically this thing's the same thing. It's a stock Ford chamber, except we fitted it with 351 Windsor valves, which is a 184 intake and a 154 exhaust. And that's that. We'll see what it does. Okay, the next one we're going to test here is the same Ford head, unported. Only this chamber here is fitted with Chevrolet valves. It's got a 194 intake and a 160 exhaust. See what it does. All right, next one we're going to do here is the end chamber, and that's the one where we put the 194, 160 Chevrolet valves in, but we've ported the intake and the exhaust runners. We're using back cut valves, and the combustion chamber is unshrouded around the valves. Speaking of unshrouded, let me tell you something. I spoke about this earlier in the segment about shrouding and shrouded valves and unshrouded valves. And by going to a bigger valve in a small chamber doesn't mean you're going to get better flow. Let me give you an example of that. Just for proof right here where the fat lady sang here, and she doesn't lie. What the deal is, this chamber right here had the 184, 145 valves. That's the 351 Windsor valves. That one on the exhaust side flowed at half-inch lift 123 CFM. When we came over here and we put the Chevy valves in this, in the same chamber, same untouched chamber, but we put a 160 exhaust valve in there, at the same lift, at half-inch lift, it only flowed 116 CFM. So that's quite a bit of difference. So just by going bigger doesn't mean you're going to flow better. And that's proof positive right there. We'll go ahead and have Mike test this chamber right here and see what we get on this one. All right, well, Mike just flowed this last segment of the head here in this last chamber. That's the one with the Chevy valves, a 194 and a 160 in it, with the ported intake and a ported exhaust. Now, mind you, this is not a wild port job. This is actually gasket matched to a stock gasket size, but cut all the way out and just shaped inside. Same with the exhaust port. It's to a standard header gasket size. It's not a great big one or anything. Let me just give you the comparisons between the ported with the good valves in it to the stock one. The stock one, we started out, on the intake side at 500 lift, 174 CFM. It's not real great. On the exhaust side at 500 lift was 113 CFM. Not very good. When we go to the ported one right here, same thing at a half-inch lift, we ended up with 198.6 CFM. It's a pretty good jump. So we went from 174 to 198.6. That's a substantial jump right there. On the exhaust side, we went from 113 CFM to 145.4. That's quite a bit of a jump. I mean, that's more flow into the cylinder, more horsepower. You can do this at home on your own time, just a few hours of porting, and a pretty substantial horsepower increase. All right, what we're going to check here next on the flow bench is an out-of-the-box Edelbrock Performer RPM head. The only reason we're checking this is just to get a baseline on what is a good performance out-of-the-box head flow compared to the numbers of a stock one and the numbers of one that's ported. So we'll see what this thing flows. All right, well, Mike just flowed this head here, and let me just give you the half-inch results because it's pretty substantial. On the intake, we had 248.5 CFM at 500 lift. That's substantial. And on the exhaust, we had 166.3 CFM. Let me just give you comparisons. On the stock head, compared to a stock Ford head that you probably have on your stock 289 or 302, at half-inch, on the intake, they flow 174 CFM. We went up to the ported and the Chevy valves, and we got 192 CFM. We went up to the Edelbrock RPM heads, and we went to 248.5 CFM. That's a lot. I mean, that's a no-brainer. You get a good quality head out of the box, bolt it on, and it's going to make power. On the exhaust, same thing. We had 113 CFM on a stock head. With the ported and the Chevy valves, we went right on up to 143.8 CFM, and then we jumped right on up to 166 on the Edelbrock heads. That's good flow. That's good bang for the buck. But just keep in mind, if you don't have the money to fork out for an aluminum set of heads like this, you can get good flow and good power out of your stock heads if you do a little porting on them. But you've got 60s technology against 2000s technology, and really bang for the buck, this is where it's at by the time you do the heads, do the porting, put valves in them, guides, hard seats, all that kind of stuff. It's hard to beat an out-of-the-box aluminum head, but if you're on a budget, nothing wrong with porting and doing a few little tricks and you can get some flow. All right, what's on the flow bench right now is a small block Chevy head. This is the same head again that we've talked about before, where I've done stock valves and a stock chamber, stock ports, unported, to where the next one has stock 194, 150 valves, but it's ported. We'll test that. Then this one right here has a 202 and a 160 valve in it, unported. Then we come down here, and this has a 202 and a 160 valve ported. So we're going to test the parameter on this just like we did the Ford head. So we'll turn Mike loose here and see what we got. All right, we just tested the first stock port here. Now we're going to come on over and test the second port. This one is basically the same valve, same everything, but it's ported. We'll see what this one flows. All right, well, Mike's getting ready here to flow this, this particular port right here, or this chamber right here. And this one has 202 intake and 160 exhaust valve. And I know we've talked about this before. You hear people saying, yeah, I got 202 heads. Well, this is a head fitted with 202 and 160 valves. It's not ported, so this one right here is just a stock port. So let's see if the bigger valves float any better than the 194s and 160s. All right, well, we're on the last end of the head right here. This is the chamber that has the 202 and a 160 in it, but it's also ported. And mind you, it's not a wild port job. This is ported to a 1205 gasket and just a standard header size gasket over here. It's not overly large or anything like that. This is what your typical street strip job would be. I want to point something out though. On this, this chamber right back over here, we had the 202 and a 160 valve put in it. I want to tell you something on the numbers right here. Just to give you an idea, the very first one we tested down here with the stock valves, a 194 and a 150, it flowed 208 CFM at half-inch lift. This one with a 202 valve flowed 208 CFM at half-inch lift. And it didn't flow any more than that, beyond that, at 600 lift. It's still 208. So what I'm getting at is you hear the wives' tales, you know, I got to have 202 valves or whatever. It didn't make 1 CFM difference. Just to give you an idea, the ported 194 valve, okay, now mind you, this is a 194 valve. The ported one flowed 220.6 CFM at half-inch lift, where the 202 and an unported flowed 208. So we lost compared to going to a 194 valve. So the old wives' tales about stuffing 202s in there and stuff just doesn't hold any water. And the flow bench is showing it here with raw proof. So let's see what this last one does, and we'll see what we get out of it. All right, well, the last head we're going to check here is a out-of-the-box Edelbrock Performer RPM. Again, your really good quality street and street strip head. We're going to use this as a baseline just to check against the last head we did. And we'll go ahead and get a test on this and see what Mikey gets out of it and check it against the other head. All right, well, Mike just flowed this aluminum head here. I'm going to give you the numbers on that, but let's wait a second. I just want to reiterate on one little thing here. On the cast iron head, on the stock port with the 194 and 150 valves, we're going to use this at a half-inch comparison because a lot of the performance cams are at 500 lift, okay? So we're going to compare this at 500. The stock head flowed 208 CFM on the intake and 136 CFM on the exhaust. The one with the 202 valves and the porting and the unshrouding flowed 235 CFM at half-inch on the intake and 156.6 CFM on the exhaust. That's pretty good numbers. That's not bad for a little bit of homework and backyard grinding. Let's check this out, though. We'll go to this head right here. This aluminum head, right out of the box, we didn't touch it, at half-inch lift, flowed 253 CFM. That's about 23 CFM more than what the ported version of the cast iron head did. And then we go down on the exhaust, and at half-inch it flowed 167.9 CFM. That's a really good number for an out-of-the-box head, comparatively to the ported head that flowed 156.6. So, you know, out of the box, I mean, it's hard to beat 2000s technology here for the money these days. It's good bang for the buck. And like we talked about aluminum before, it's lighter, it runs colder, it's repairable, and we talked about all the wives' tales before, you know, but it does not warp and it does not crack and things like that. It's hard to beat a good set of heads like these days. But if you don't have the money to spring for some of these, hey, a little bit of grinding and a little bit of port work, and we showed you how to do that earlier, you can get some pretty decent flow numbers and get some pretty decent horsepower. Put that to work, and you'll be able to up your horsepower and have a little bit of fun with your car. All right, well, that pretty much concludes this segment of our power building video series. Hope you learned a lot, and I hope we were able to solve some of the mysteries of the valve train for you. Go out and have some fun. You can do this yourself, and remember, knowledge is